So first we have to find d per d theta of 2 minus sine theta on cos theta. So let's have a look at that. So we're differentiating 2 minus sine theta on cos theta with respect to theta. So we're going to use the quotient rule. So if we differentiate the top, minus sine theta becomes minus cos theta, and times by the bottom, so we're timesing by cos theta, so that becomes negative cos squared theta here. And then differentiate the bottom, so cos theta, and we're minus, so we minus the derivative of the bottom, which is negative sine theta, so that's going to become a plus sine theta. And we're multiplying by the top, which is 2 minus sine theta, and we're dividing by the square of the bottom. So if we simplify that a little bit, we get minus cos squared theta. We're also going to get a minus sine squared theta and a 2 sine theta here, all on cos squared theta. And you can see if we put a minus factorized by a negative, we've got sine squared plus cos, or cos squared plus sine squared, doesn't matter which is 1. So, oops, on cos squared theta. So you can see we are going to get 2 sine theta. I'm just rearranging that one first, then this one. So minus 1, there's a minus there, all on cos squared theta. So we are going to get that there. Alright, so that's just using the quotient rule. So then, hence, it says, so we're going to use that, hence, find the maximum and minimum values of the expression in the interval, so it's kind of important, of 0 to pi on 4. Alright, so we know that if we set it to 0, we're finding stationary points if we set the first derivative to 0. So let's set that to 0. Now if we do set that to 0, just be careful, we can't have cos theta equaling 0. What we want is the top to equal 0 without cos theta equal 0. So if we rearrange that, we are going to get sine theta equals a half, and in that space 0 to pi on 4, the only answer there would be pi on 6, 30 degrees, and cos pi on 6 does not equal, cos 30 is root 3 on 2, so it does not equal 0. So we're all good with pi on 6. So what we're interested in here is looking for maximum and minimum values in this interval. So we're really interested in theta equaling 0, whoops, there we go, 0, pi on 6, and pi on 4, because 0 and pi on 4 are the end points. So they could be maximum and minimum values in that interval. Okay, so let's have a look. And again, I'll just rub that out so we've got more space. Alright, so that's what we're interested in. So let's go back to the actual function, 2 minus sine theta on cos theta. So for theta equals 0, what do we have? We have 2 minus sine 0, whoops, there's 2. Sine 0 is 1, no, sine 0 is 0, whoops. On cos 0, and cos 0 is 1. So we're going to get 2. So for theta equals 0, we're getting y equals 2, if this is our y here. Okay, and then let's have a look at theta equals, oops, not writing. Theta equals pi on 6. What does y equal? So if we look at that, we get 2 minus, so pi on 6 is 30, sine 30 is a half, and cos 30 is root 3 on 2. So we are going to get a 4 minus 1 is a 3 on root 3, but 3 on root 3, if I multiply by root 3 on root 3 is just root 3. Okay, so I'm going to put a root 3 there. So y is root 3. And then for theta equals pi on 4, what do we have? 2 minus 1 on root 2, sine 45, and cos 45 is also 1 on root 2. Alright, so if I multiply by root 2, I've got 2 root 2 minus 1 on 1. Alright, so you might want to put those in your calculator and just see, but in that space, that interval from 0 to pi on 4, we don't need to double dash, we can just see the y value of each of those 3 important points, the endpoints and the stationary point. And you can see 2, so this is the maximum, so this will be the maximum value in that interval at theta equals 0. And root 3 is less than 2 root 2 minus 1, so this is going to be the minimum value in that interval at theta equals pi on 6.